This is a little comic. I tried to deliver this in the mirror several times. I didn't sound funny, so read it, giggle to yourselves. But ultimately, I think the point of this slide is to say, today AI is coming to your doorstep, and we want to be able to simplify and navigate the world of AI for you to accomplish some value, right? So without further ado, I do want to cover our slogan, our marketing slogan, artificial intelligence with a human touch. So this is a very deliberate saying that we've incorporated into our brand because of the way that we deliver artificial intelligence solutions. So part of my work in the past has been running design thinking chapters for large tier 1 organizations. And design thinking, for a show of hands, who knows what design thinking is? Nobody? Okay, good. So one person. So design thinking is essentially a framework that helps you design solutions from the user's perspective. It borrows from Agile, it borrows from Scrum, it borrows from applied psychology. It's supposed to remove your biases to understand the users of the system and create collectively designs that are technology agnostic. So ultimately, we've incorporated that into our approach, and thereby we create an understanding of the true problems that are inherent in various verticals that you're all from, and build solutions that are relevant to those problems. So why should AI matter? Read this very quick. Who can answer this question for me? Any idea? Any thoughts? You get bonus points if you get the right answer. Free AI consulting session. Anyone? So today, a lot of the barriers to adoption of artificial intelligence have been removed. There are tools available that allow you, without programming skill, to bring AI to your doorstep. There are many more vendors in the market today offering AI solutions. There is cloud computing available to you at a lower and lower cost to be able to build those AI models. So ultimately, AI is no longer a multi-million-dollar solution for you. Okay, I tricked you by asking that previous question about who's the decision maker. If you guys can raise your hands, the decision makers in the room. Greg, raise your hand. So, how many of you have implemented AI? So I saw 5 or 6 decision makers and 1.5 people implementing AI. So this statistic from Forrester speaks to the leading corporations within their vertical, and leading defined by exceeding their average industry performance. And so 63% of these folks are implementing AI today. So just food for thought for those of you considering artificial intelligence. Part of what defines success for these leading individuals is to adopt technologies like this to automate processes and to bring values to your organization. Okay, what we will cover here today in terms of technology, I won't dive in too deep into the technical pieces. I think you've got a flavor of this yesterday a little bit with a few presentations, and hopefully you have some understanding. We'll cover natural language processing and chatbots, computer visioning, neural networks, deep learning, and machine learning are kind of grouped together. So kind of the gamut of what is today considered the core artificial intelligence cognitive solutions that are being delivered into the market. So before I start with the theory and the practice, just a little bit of the right approach and the right philosophy of looking at artificial intelligence. So although this presentation is geared mostly around AI, I am the AI and IoT practice lead, and that collective way that we've offered both solutions is very deliberate. And this kind of speaks to the reason why. So as an organization, you should be looking at AI at some point not as simply a technology, but an enabler to fill gaps in your information. The idea being, you look at your corporate strategy, you determine what information can achieve specific goals in your corporate strategy, and then you decide what you have already and what you need. And AI and IoT can fill those gaps for you. Now that's kind of an oversimplification of what is required in order to actually build AI and IoT solutions and collectively deliver value. But this is a good guiding light as you mature digitally as to how you need to approach artificial intelligence, which means, depending on where you are in your digital maturity, it may not start with AI, but it may start with data cleanliness, centralization of data, feature engineering, all these things that are the fundamental components of being able to deploy artificial intelligence successfully. So I mentioned design thinking. This is part of our right approach that I mentioned. So in order to deliver value, you have to design solutions that are functional, obviously, but actually in the short term, immediately highlight some relevant, low-hanging value that can be presented within your organization, especially if you don't have corporate-wide initiatives that are dictating to you that you need to roll out some digital strategy that revolves around artificial intelligence. If you are, let's say, the stakeholder within your organization that is looking to try to drive artificial intelligence, approaching AI this way allows you to bring a group collectively together, agree on problems, and agree that AI is the best solution to those problems. Now, if you're interested in learning a little bit more about design thinking, you can come to our booth, speak to us after. It's essentially an entire different framework that we also offer alongside artificial intelligence and IoT technology delivery. Okay, so the purpose of this slide is to say that today's presentation, I want to touch upon some relevant idea that you may have in your head or that maybe will come up in your head based on covering as many vertical markets as possible in this presentation, based on being very visual and based on covering a lot of different artificial intelligence sub-sciences. So I'm trying to basically spread the realm of possibility to you and have you guys think up possible ways where AI can work for you, and then hopefully reach out to us and we can further discuss those ideas. So this is really our only branded-like slide that speaks to our specific product called Vera. So Vera is our artificial intelligence framework. It provides tools across a realm of different artificial intelligence solutions for us to build specific solutions that solve very specific problems for various vertical markets. What I'll cover today, which is essentially kind of the core three technologies: natural language processing, which is a little NLP icon, computer visioning, and deep learning. Like I said, I'll give you guys a flavor for what that is, and then I will give you very tangible examples of how we've used it. And I'll do that across several different vertical markets: pharma, oil and gas, smart appliances, industrial manufacturing, and office automation. So really the spectrum of the realm of possibility. Okay, who has heard of a neural network? Who knows what a neural network is? Okay. I feel like the people that said they've heard of it didn't raise their hands, but they said they know what it is. So. Last time I explained this technically, I got deer in the headlight sort of look. So I will, to avoid everyone from staring at me in confusion, I will just explain this to you with an analogy. So first of all, this is really just a software program that mimics learning the way that the human brain learns. Without getting into the mathematical details, imagine your input layer to be essentially the features that you're looking to observe, your output layer to be the outcome that you're looking to correlate to the features that you're observing. And imagine glasses of water being poured through each of these hidden layers. And as you fill up those glasses, when they get to the top, they'll pour over to the next layer. If they don't get to the top of that glass within each of these little circles, that little glass won't pour over. Once all the glasses have poured over to the output layer, if that output layer's glass is full, then bullseye, we've hit the right size of glasses that we need in order to get to the output layer correctly. if that output layer glass wasn't filled up all the way, then we do what's called back propagation, which is we say, what is the difference between how much water we filled and how big that glass is, and then we adjust the rest of those glasses in the hidden layers by size, and continuously do that pseudo-randomly in order to get that water to fill up perfectly into that output layer. Once we've done that, then our glass sizes can now predict future outcomes. So I'm getting less deer in the headlights this time around, so I hope that created a relevant analogy for you guys. Of course, we welcome further discussion, and we can dive into this technically with you guys if you want to explore this at a technical level. I won't even cover this in this level of detail, but I wanted to highlight this because it's an important neural network that's used a lot in natural language processing. And essentially, all you have to remember here is there's a forget layer, or a forget input, an input layer, and an output layer. And the reason we have a forget cell or layer is because when we use neural networks to process text, we tend to, when we train this neural network, do something called disappearing gradient, which is basically we forget about things that we try to teach the neural network at the beginning of our sentence, and so it starts losing meaning. In order to be able to accomplish processing of natural language text, among other things, we use what's called an LSTM, which is a long short-term memory neural network. Now, by a show of hands, who knows what natural language processing is? Okay. So basically, it's an ability of an artificial intelligence to take large volumes of text and create and process insights around that text. So we as humans don't do a very good job of reading through large volumes of text and actually creating correlations between that large volume of text, right? If you have 1 million pages of natural language text, and maybe those pages are in product manuals, standard operating procedures, maintenance records, doctor's notes, that information is very difficult to bring collectively into a statistical model. So why natural language processing? There's many reasons. Part of it is it's kind of the fundamental capability of interpreting natural language information as you write to a chatbot, which I'll get into later. But one of the unique differentiating reasons why you should consider natural language processing in your AI technology roadmap is it will bring in a whole new dimension to statistical analysis by bringing in natural language text that you've never really considered before and gaining insights out of that text into your statistical models. Now, what that means for you, I'll hope to be able to touch with one of the case studies, but think of that as a guiding light for you when you're looking at natural language processing. Here's some statistics for you. It's an industry that is growing at 24% per year. It will be worth $16 billion by 2021, so some just relevant quantified statistics for you in terms of where and how natural language processing, natural language understanding is growing. Case studies. Okay, great. So before I get into this case study, I will talk a little bit about chatbots and virtual assistants. So I'm going to interact with you guys again. Who knows what a chatbot is? This is probably the easiest question in the session. Okay. So chatbots, traditionally, if you've ever used one, tend to have various limitations in terms of how they can interact with the user. One of the fundamental limitations is they tend to be designed statically using a rule-based approach in terms of how they process information. So you ask it a question, it has a list of answers from which you can answer that particular question with. That limits its ability to answer new questions. It limits its ability to be able to interact with the user and actually create a satisfying experience out of that chatbot interaction. So some of the fundamental architectural things that we've built into some of our offerings include ways of building chatbots that can not only statically answer questions, but dynamically look at data and determine what possible answers it can provide, regardless of what we've hard-coded into the chatbot. There are also other nuances in the reasons why you may want to adopt a chatbot. And perhaps the reasons why you couldn't adopt a chatbot, one of them is everybody writes a question differently, right? So if Greg writes a question and Purna writes a question, sorry, that's the two names I quickly caught. Both of those questions may ask the same thing, but may use completely different words to ask that same question. So part of natural language processing is its ability to then say, these are actually the same questions being asked. Again, without getting into the technical details, the power of that capability allows for an interaction to be authentic and allows the user to be able to get answers very quickly without having to memorize keywords that they need to say to the chatbot. So this case study is actually very interesting. It is for a large pharmaceutical company, and it has this pharmaceutical company, 300 or 400 lab scientists that are looking to perform experiments in order to essentially collectively build and drive a particular product to market. Each day, this pharmaceutical company and these lab scientists used to spend 30 to 40 minutes reserving lab equipment, because that lab equipment information was sparsed across 4 or 5 different application platforms. One of them was asset management, another was facility diagrams, because they needed to understand relative to where they were, where they needed to go. And so this process took a long time, and it took time away from productive work. Hopefully I can play this. So I'm going to try to talk through this as we load. A little bit about this interface and about the interactions. And I'm going to allude back to our human touch slogan. So when we build chatbots, a lot of the times we do so grounded in design thinking, where we're trying to capture nuances in both the visual interface and the user experience in order to provide a seamless way of interacting with the chatbot based on that specific user. In this case, we call it in design thinking a persona. Our persona is a lab scientist, and we have to understand that persona in order to build an experience that is most relevant to them, right? So in this particular case, because lab scientists don't spend a lot of time at their office, they're out in the lab a lot, part of the design decisions for mobile interface was because we want for them to be able to access this platform not just on a desktop, but through a mobile application. The other unique capability that's very relevant is what's called personalization. We call it user insights. And it's this idea that says, if you're talking to me as a subject matter expert across the room, you don't want to have to answer questions that are very obvious or redundant, right? So if I ask you, pass me that flower, don't do that. But I'm not going to ask you which flower or where, what building, right? I'm going to have context immediately that will provide you information, if you're the chatbot, that you can pass me that flower, right? So personalization reduces redundant questions, reduces that friction that is often created if chatbots don't personalize. And friction creates escalation to live agents or people that are just disgruntled that don't want to use the chatbot anymore. So if you're looking to adopt a chatbot, these very specific features are very relevant. The other is essentially digging deeper into your specific role. If you're a lab scientist, if you're working on an experiment, it's a lot easier if I already know what experiment you're working on, so I can recommend things based on my knowledge of data that exists within your profile. So that entire capability allows you to accelerate the whole workflow. So I wish I could fast forward through this. Can we click on the middle of that presentation, Don? Just the video, if you can click in the middle. Jump to the middle of that video. There should be a little right down there in the video. I want to highlight one other unique, that's not the right way. So I want to highlight one other feature of our chatbot that is very relevant, and it's this idea that says, part of the reasons why chatbots can't answer complex questions successfully is because they tend to give you text dumps or links to documents. What we've wanted to provide to the user is the most authentic and the most seamless media to, no, this is the wrong video, to the user, right? So if you're giving instructions to someone as to, let's say, where that lab equipment exists, you don't want to necessarily give them a text dump of a bunch of information with a bunch of different building names and building codes that they'll have no way of appropriately interpreting. You want to give them a diagram and show them exactly where they need to go in that diagram, like a real subject matter expert would to that user. So those are unique things, authentic interactions that are created that allow more complex problems to be resolved. Did everybody get that? If they all got that, we don't need to show the video.
Question.
Yes?
So are people beta testing with real humans, specific question that's asked, and then the typical answers, and those are logged, like a true false, and correlated to the most likely?
So that is the front-end approach to be able to collect questions and then optimize the correct answers. You do have like a feedback mechanism for test groups, but not all your questions are generated from the user. Like I mentioned, the limitations to what you can answer are not based on one subject matter expert, but ultimately are based on all the data that you have. So part of the unique capabilities of chatbots that can address those sort of collective approach of being able to answer any question that can be asked is looking at the data first and generating questions automatically from that data. Possible questions, permutations of questions.
Are you programming responses automatically with that, and then using that correlation to kind of figure out which one will make the most sense?
So yes, and there's programming, I'll say, is kind of loosely used, right? So programming can mean a rule-based approach, or it could be using that LSTM neural net to actually generate sentences on its own, right? Based on the possible question that can be asked. Okay, we'll just skip this. You had the right thing going on this one. So this is another, we can go back here. This is another really interesting case study. This is actually for one of our largest clients. It's in the smart appliance space, and it kind of, at a very raw code level, highlights the value of natural language processing in a unique way. So this case study is basically the ability to take cooking instructions in diverse forms, because there's millions of different produce out there that you can cook, microwave, etc., and process them so they can be automatically consumed by a smart appliance, and that smart appliance can self-program itself on the right temperature settings, the right time, and so on and so on. What you see here is a raw cooking instruction. So that is just one example of a cooking instruction. Can you go to 141 on the video? Would you be able to go to 141 on the video? Or 150? Yeah, keep going. There it is, 140. There you go. A little bit back, 141. There, you can pause it right there. No, that's not pause. Who got that? It was really quick. It was a flash. So what I wanted to show you, as we load that 141 again, is basically you saw the raw text. That code is the structured JSON formatted file that has various cooking steps and parameters that were extracted using natural language processing, structured regardless of the format of that cooking instruction, which is extremely diverse, so that the smart appliance can correctly consume it. Yes, sir?
So while we're finding this, would you just then give 3 use cases to the audience to kind of, I don't mean to put you on the spot, but you could
3 use cases of?
whatever that we're doing, that we're working on.
I have much more than 3, and we're getting there. Greg, I thought you weren't an IT decision maker. We downgraded you. So I will cover them, but I think we're okay here, so I'm just going to skip ahead. So this, again, I wanted to just give you guys another look at the various types of user experiences that we build through our chatbot and powered through natural language processing, grounded in unique ways of personalizing those experiences and providing information. We've done that across a variety of different vertical markets. There are web links, demos, videos available to you. All you got to do is reach out to our teams here, and you can dive deep into these sort of experiences and really get a feel for what value chatbots, and our chatbot specifically, can bring to your organization. Okay, this is the fun stuff. So if you guys are bored, you're going to get on board very quickly. Computer visioning and CNNs. Who knows what a convolutional neural network is? Anyone? Some people are pretending, I know that, because they were on my previous presentation. So convolutional neural networks are neural networks, as I explained them, that are designed to be able to do image processing and identify objects within an image. Very simply, if I want to train my convolutional neural network, the difference between a cat and a dog, I will pass it many examples of a cat, many examples of a dog. I will tell it this is a cat and this is a dog, and over time, it will understand unique features in that image that will be able to distinguish between a cat and a dog, and we will be able, with extremely high probability, some of the image processing platforms do it to 4 or 5 degrees of accuracy, the difference. Now, there's probably no real practical reason why you'd want to do that, unless you work in some sort of industry that you have images of cats and dogs you want to separate. But fundamentally, this can be scaled into very, very unique computer visioning capabilities, and I'll share with you some of those in our case studies.
How many samples does it typically take?
Well, so I would say for cats and dogs, you don't need to do anything, because if you're interested in that one specifically, because there's out-of-box solutions that will give you that instantly.
I'm just thinking, like, if you're
But if you're doing specialized training, if you're doing specialized training, I would say for industrial purposes, for pharma purposes, the ballpark number that we use for supervised learning is about 10,000. And you split those up into a training and test set, and then you basically train on one set and you test on the other, you validate your accuracies and you adjust your parameters and so on. But as an example, and I'll show you something soon, sometimes you don't have access to 10,000 of that type of image because it's very uncommon that it occurs, right, if it's a defect. And so you do things a little differently that way. You do what's called anomaly detection, and you train the neural network to understand the normal, and then when it doesn't see normal, it essentially identifies something that's unnormal. Yes?
Just want to make sure I'm tracking with what we're talking about here. Is this similar to like the tech that's used for Google Lens?
No.
No, okay.
But, yeah, Google Lens, no.
Okay.
But you'll get a little flavor of it in a second. There's a lot of visuals here that I think will articulate this for you. So why computer visioning? Well, I speak to this kind of high-level collective metric that was provided by Gartner, which is AI augmentation will generate $2.9 trillion of business value and recover 6.2 billion hours of productivity. I think because this is a collective statistic, I want to highlight the second one specifically for computer visioning, because I feel that this specific technology within worker productivity is extremely valuable and saves, with each of our case studies, a tremendous amount of time because of its ability to do things faster, do things more accurately, and that then translates to a lot of cost savings and productivity savings. Why? Is that me, guys? Or is that's not my heart, is it? So one of the reasons why you need to look at this is kind of this crossroad example. So today, computer visioning resolutions are growing exponentially, so you have much more refined image capabilities. You have obviously this whole notion of computing power being accessible to you, which I mentioned to you earlier, so cloud platforms are available to you that you can host these AI computer visioning models on, so you have accessibility to power. And you also have the evolution of neural networks and convolutional neural networks and other unique image processing algorithms that can process high definition video feeds in real time and give you a tremendous amount of insight around that video feed. And of course, last but not least, just the growth of data in any form, in this particular case, images, right? That collective crossroad means that today, computer visioning is a very important AI technology that can bring value to a lot of different organizations, and I'll cover that right now. Okay. So this is one of our case studies. It is what you're looking at here is a drill pipe and a thread on a drill pipe. And basically, computer visioning, traditionally, when it was implemented in the industrial sector, used rule-based algorithms that were looking to find defects in whatever product it was looking at. Rule-based algorithms means it's looking for contrast changes or something different in a scripted way, and then simply telling the operator or some sort of supervised controller, I found something, I don't know what it is. What artificial intelligence does is it actually is able to autonomously identify exactly what that specific type of defect that it's looking at is, and it classifies it, and then that then allows that operator to serve, well, first of all, as a subject matter expert to build this artificial intelligence network, but also that worker productivity metric that we saw, 6.9 billion hours of productivity, that is fundamentally grounded in things like this that can be brought to the industry. So if you have 5 operators doing visual inspections, because you need them there to visually identify and categorize product, autonomous artificial intelligence can now allow that productivity to be focused elsewhere, right? Because inspection tends to be a time-draining process, a bottlenecking process, and now that bottleneck is also removed from that production line, so your production throughput can be increased, and there's a lot of kind of follow-up value behind that, right? Better customer service, you're providing a digital certificate with an elaborate understanding of the defects on that product, you're enhancing your customer relationship, so there's kind of a trickle effect of value that can be brought through automating processes like this. Any questions on this? So this is another project that I personally was involved on. This is the world's largest vessel. It's called Shell Prelude. It's a floating natural gas plant. When I was there in South Korea, it was still being assembled. It's now moved, I think, west of Australia and is essentially processing and liquefying natural gas in the ocean and then putting it on tankers to allow it to ship to the local markets instead of having to bring it back to Australia, process it, and ship it out. So it's a $35 billion project plus. The work that we did on this vessel is to control contractor safety. So this is a combination of IoT and AI working together. You have 5,000 contractors, rotating contractors, doing a variety of different tasks across the entire vessel. And those contractors have health and safety requirements in terms of certificates they need for welding, for other activities. And they also have the need to actually wear their personal protective gear at all times. What we've built is essentially an AI IoT turnkey solution that controlled entry and exit on the vessel on these, they call them gangways, 8 different entry points. And on the vessel, various control points that were powered through AI visioning that identified hard hats and safety glasses, and if those individuals were wearing the correct personal protective gear. So a really nice example of applying it, AI, IoT technology, turnkey, to deliver health and safety value at a very large scale. This is another industrial example of computer visioning, and it shows the power of being able to use computer visioning for measurement, structural integrity of sort. This is probably the most granular example where I would use this sort of technology, but ultimately imagine any object running through your production line. You want to determine if it's equicentric, if you want to determine if the dimensions of a particular part of the object very quickly in real time, so you can speed up your inspection steps. Normally, measurements like this are done with calipers across multiple points on the pipe. Those calipers have to be maintained and calibrated. Every operator, depending on how much they had to drink the day before or whatever it is, tends to do measurements differently. So you're going to have inconsistent information, uncalibrated calipers, a lot of time spent measuring, whereas this can happen instantly, right? Instant measurement using computer visioning, which is an extremely powerful tool across a lot of different industries. We're okay on time? Whoa. If we can play the video on the left. Oh, there we go. Okay, I think we're okay. So this is a nice example. Yes, sir.
Is this like a mobile eye technology, or what is this?
I'm sorry?
Is it like mobile eye, or what are they? What kind of
Visioning. This is off of a mobile phone. And you,
software you guys have?
I'm sorry?
Is this software you guys have specific, or are you just showing?
No, this is ours. Yeah, this is our project. But so I'm gonna just highlight a lot of the cool stuff is not actually there. This is really easy to do. The cool stuff is there, and then the next slide that I'm going to show you. This is extremely valuable for health and safety people, and really anyone in any industry from the perspective of data analytics, because we can all tell those are people in cars, right? That's not giving us any insights. What we can't identify easily is how much time people spent in front of that car. What is the response time? How long did the fire warden talk to his individual team? What was the response times of the vehicles? All these analytics, if you wanted to accomplish the insights on the back end that are being collected, would take you 10 people, and even then you probably wouldn't be able to get the data that you wanted out of this, right? So regardless if this is health and safety or some marketing or retail application, computer visioning is bringing, like natural language processing, and a whole different dimension to analytics to your doorstep that you may have never thought of, that you definitely didn't know. The second video is not going to play on this PowerPoint, but I welcome you guys to reach out to us and we'll show you it. This is an example of an oil rig that is controlling the personal protective equipment of the individuals on the rig so that they're always wearing their appropriate PPE gear, personal protective equipment gear. So really, I wanted to highlight kind of the top level view, the medium level view of breaking down objects on an individual, and probably the most granular view of AI visioning, which is at the skeletal level, right? So here, the camera visioning system is actually able to determine my joint movement. This is used, in our case, for office ergonomics and for proper lifting techniques in industrial environments. We've already discussed with a few other folks a lot of different sports-related ways of applying this technology, so you can stream data and understand movement. So it's not just about seeing this video feed, but about the data that's being collected on the back end that will tell us how quickly someone is moving, if they're using the proper techniques, et cetera, et cetera. Any questions so far?
The security things where I have to identify somebody's cars or where the traffic lights are you using any of that data to help develop your...
Sorry, can you repeat the question?
When there are security things that when I log into a website, say which pictures have a card in it.
Which pictures have, oh yeah, so
So I have to answer which pictures have a card in it.
So you know why they do that? Because they're using you as a supervised learner.
And are you using that?
So I think those types of capabilities in industrial environments, we've done it a couple of times, but really the value of that sort of approach is if you have a portal where millions of people go on every day to search for things. I won't name anyone, but those large volume portals that force you to authenticate for some reason allow you to use, essentially transparently supervise, learn the algorithm. So we've done it, but our audiences sometimes they're too small. I mean, even if it's a 2,000 person organization, they're not going to go more than a few times per day on a particular site to be able to use that supervised mechanism. So in a lot of the cases, when you're training data, you need to bring a subject matter expert or a collective group of subject matter experts. And if you're training on data that you can actually have pictures of, then you approach your AI roadmap, but by first collecting data, which I mentioned in kind of the early slides, the right philosophy slides, build your data foundation, and then from there you can leverage artificial intelligence to be able to do very cool things like this with computer vision. You probably were looking for a shorter answer, but hopefully I can answer.
Yeah, so when we're doing that, we're working for Google or somebody for free.
Yeah.
Okay.
Okay, so this actually is a really nice, tangible example of what I highlighted at the beginning with the thread in the pipe. We have this, or we will set this up at our booth or in those tables, It's essentially an aluminum sheet we will let you guys interact with. We'll give you a couple of tools. You can damage it, color it, scrape it at any place, throw it under a web camera, and it will, in real time, identify the specific defect that you've created on our aluminum sheet. Aluminum sheets are limited, so please come to our booth if you want to be able to interact with this particular nice example, tangible example of artificial intelligence computer vision. Okay, so this is a pretty simple graph, and I think I've highlighted this before, but I want to mention it again because I think it's important for those of you who have worked in the analytics space to disrupt your frame of approach and thought around what deep learning is, what statistical analysis is. There's very tangible information available to you today that will show you that deep learning with 2 orders of magnitude is superior in accuracy and precision to be able to provide insights around data with large volumes of data. So if you've used statistical analysis before and your perception is, I already know about this, I'm already getting value, rethink that approach because neural networks and deep learning bring a whole different perspective and a whole different capability around what you can do with that data. So another Gartner quote I think that's useful here. Essentially, what we're saying here is that leading organizations, leading CIOs, have prioritized artificial intelligence as a top priority technology initiative in the next 3 years. Again, leading defined by outperforming your vertical market across different metrics. The other interesting statistic from Deloitte is, well, what do CIOs think in terms of where they're going to be hiring and what gaps will exist in their efforts? And it's in data science, analytics, and business intelligence. 64% of the respondents said that that's the particular role that will be needed and that will be missed because of the lack of capabilities in the market in the next 3 years. Right, I think this gives a little bit of a different flavor to AI deep learning. This is a large finance company that has a call center that supports troubleshooting of a variety of different IT problems. I think they have several million tickets a day that they receive. And one of the business problems that they had is their call center was pursuing problems that were not in the scope of their service level agreement because initial symptoms of those problems indicated that they need to dive down and try to resolve. But the reality of it is a good portion of those calls were actually unrelated to both them in terms of their infrastructure and their service level agreements. Mm-hmm. So what they wanted to accomplish is get a platform, a deep learning platform, build a deep learning platform on their data that will give them insights into what I call their soft variables. Things that are not related to typical symptom analysis, like who that individual is calling, what infrastructure they're using, how many times they've called in the past, what are the live agent notes that we weren't able to before bring into the system because there was no natural language processing capability, and collectively harness that information to then say, well, for these specific problems, don't waste the tens of thousands of hours of productivity and cost because they're not within the scope of what you need to handle, right? So a really nice tangible example of looking at historical data. They had tons of different historical data in different forms, categorical, non-categorical data. So in other words, categorical means there's only a multitude of possible options. Non-categorical, it could be just notes or just numbers. And then bringing that into the deep learning model, filling those vials of water, adjusting their model, and then having the ability, based on new information, to then predict, is this a valid call that I need to handle? Okay, last but not least. This is another one of our flagship products. It's called AI Pyramid. It's basically an office automation tool. It was initially designed with the intent of doing conference room headcounts. The purpose of the conference room headcount requirement came out of 2 different departments. One of the departments said, I just want to know conference room occupancies because I have a large campus and people don't respect Outlook calendars, and then they have to spend 20, 30 minutes looking for a room, going to a room that's five buildings away. A lot of time wasted, right? Smiling because that happens, right? It happened to me also. That's why we built this. And of course, you can have industrial or office automation sensors that can give you motion, that can give you some semblance of, is someone there? But then another, let's say, stakeholder came into the mix and said, well, we want to know the count, because then we can determine space utilization. Because those people that are booking those rooms are now going into a 40 or 30-person conference room, and there's only 3 of them because they can't find a room. So let us better use our space, break down those conference rooms. So now, powered through computer visioning and an omnidirectional camera, which we can also demonstrate to you at our booth, you'll be able to essentially get a conference room head count that is fed into both occupancy and the Outlook calendar and space utilization. The last stakeholder that kind of evolved over time was a project management group looking to do automatic transcription and minutes of the meeting generation out of those meetings. So we've just started that recently, and we're evolving it. We have some cool transcription technology as well.